Good morning. How are you? I hope you're doing well. So we have started a new chapter, chapter 9. The first part of chapter 9 is graphing something called a quadratic, which forms this beautiful curve called a parabola. So we're going to learn how to graph parabolas. No T-chart like middle school. You had to plug in all these numbers and there was an input and an output. We're going to be able to just look at the equation and go, I know stuff. I can tell you it opens up or it opens down. I can tell you it shifts up or it shifts down. I can tell you if it moves left or right and all over the place, called a horizontal shift and a vertical shift. So we're going to learn all of these. So let's talk about the basic, just a basic quadratic. What the heck does that look like? Well, a basic quadratic is y equals x squared. That is the most basic form of what I'm going to cover. This one, we're going to want to memorize what it looks like on a graph because that's always our starting point. We got to remember this guy and then go, okay, from this guy, how is this more fancy equation going to shift? Up, down, left, right, all over the place, okay? But this is our starting point. It's kind of like when you're playing Monopoly and you put your little a play piece on the go. That's your go. This is always your go graph. You start there, and then from there you discuss how is it going to transform or move, okay? So let's talk about the importance of what does this guy look like? And again, this is a quadratic. A quadratic has an x value that is squared. An x value that is squared, called a quadratic, when graphed, makes one of these little beautiful guys called a parabola. Now, I'm going to do a T-chart just for this first guy, but after that, we're not going to do a T-chart again. And again, this is just an intro video. There's going to be a lot more, okay? I'm just doing a little quick intro. We are going to plug in a few random points because there's some important things to see about a quadratic. So I'm going to plug in 0 first. 0 is going to go right here. So let me write, in place of x, I'm going to replace x with 0. Help me out. What is 0 squared? Which means what is 0 times 0? 0. Ooh, that's a special point. And that sucker's right there. We're going to talk about the special name of that point in just a minute. But that's our go-to point. Next, I'm going to plug in 1 right there. So I'm going to replace x with the number 1 and see what I get. Now that's not 2, that is 1 times 1. What is 1 times 1? 1. So our next point we're going to graph is 1, 1, 1, 1. Perfect. Now, since we are making a shape called a parabola, there's something called symmetry balance. Whatever happens on this side of the graph, the same thing is going to happen on this side of the graph. So this guy has a point that's his friend that is the same distance on the other side. So this is 1 unit away. He's going to have a friend on the other side that's right there. Now, that's where I don't want you to believe me. Let me prove it to you. I'm going to plug in -1. Now, that's not just -1 squared. That's -1 in parentheses squared, which means -1 times another -1. What is a negative times a negative? Positive. And what's 1 times 1? 1. So there's that point I was just talking about, -1, 1. But we already knew it was going to be sitting there because we have symmetry or balance on each side. This is a curve that on each side, it has an equidistance point on the other side. Cool? Cool. Let's try 2. We're going to plug in 2. Y equals 2 squared. So that is 2 times 2. What is 2 times 2? 4. So starting from this 0, 0 point, we're going to go over 2, and we're going to go at 4. 1, 2, 3, and 4. Yep, he has a friend on the other side that's equidistance away. So he's 2 units away from this really dark line. That dark line's called the y-axis. This one's called the x-axis. So we need a friend, another point that's on the other side that's equidistance away. So he's 2 units. We're going to go 2 on the other side. But again, don't believe me. Why? What do I know? Plug it in. Check it out yourself. So we're going to go with negative 2 squared. So negative 2 times negative 2 is positive 4. That's interesting. That is that point, negative 2 up 4. This, my friends, you're going to connect it with a beautiful curve, very curvy, not straight lines. That is the parent function of a quadratic. It is the starting point when we start graphing the more fancy ones, okay? So I will say, using the parent function, what does this graph look like? So I'm saying, hey, starting with the start guy, what would you do when and if you see this? For instance, I'll show you one. Let me use this dark blue pen. So let's say I'm trying to graph the following. Let's go with, let me erase all of this so I have a little board space. I'm going to graph y equals x squared plus 4. And I'm going to say, using the parent function, what does the given graph look like when graphed? Something like that. Maybe not so silly sounding. So here we know this. That's that guy right there. But this is saying, hey, take that guy, the parent function, the starter parabola, and shift it up 4. So literally, we're going to take this entire thing and keep it the same and just shift it up 4 units. So I'm going to grab this point and shift it up 4. 1, 2, 3, 4. Perfect. And then you're going to shift all of the other points as well. Now, the easiest way for me is I do it this way. I know from this special point, that special point is called the vertex. It's either the lowest part of the parabola or it could be the tallest part of the parabola if it was facing downward, okay? So this point, I know that a point is always 1, 1 and 2, 4. So from this point, I go 1, 1. I include his partner on the other side, and then I go 2, 4. 1, 2, 1, 2, 3, 4. Congratulations to us. We just shifted it up 4. Well, Miss Miller, does that work if I try to shift it downwards? You mean like one of these yahoos? Well, let's check it out. So it says, take the parent function and shift it down 3. Let's do that. I'm going to go to the vertex and shift it down 3. And then I'm going to include the points around it. Again, it's 1, 1 and 2, 4. And then I need to include their partners in crime on the other side. Oh, shenanigans. There we go. Notice, the shape itself did not change. It just either shifted up or it shifted down. And this is called standard form. I don't see any crazy parentheses or anything that's making this look weird. I see the parent function and adding or subtracting of a number at the end. Well, Miss Miller, what if there was a negative somewhere? Oh, you mean like in front of the x squared? Let's check that out real quick. So first thing, I'm going to erase all of these, and I'm going to stick with that parent function. Remember, the go-to starter parabola. That's my go-to. Okay, so now what if I gave you something like this? Holy sarsaparilla, what the heck does that mean? Oh, well, let me start with the easier one. That looks like the parent function, but it has a negative in the front. If your parent function, remember this is the parent function, and all I do is change it and put a negative in the front, that negative tells me I'm going to flip it over and have it facing in a downward direction. So this point stays the same, but that negative tells me to flip it downstairs. So I know that point stays the same, and then we're going to have a 1, 1, and then 2, 1, 2, 3, 4, and his partner on the other side. Oh, yeah, I see what you did there, Miller. It's the same graph, it just flipped over this beautiful x-axis. Cool. I wonder what happens. Let me use a different one. Use a different color. How about red? I wonder what happens if I do a flip plus move up 3. What the heck would that look like? Well, first thing I would do is start with my parent function. I know what that looks like right there. So now you have to use your imagination, your spidey senses. Here's my parent function. I'm going to flip it down and then scooch it up 3. I'm going to flip it down and scooch it up 3. So let's do that. I'm going to flip it down. So that's my 1, 1, and then my 2, 4, 2, 4. So I did that part. I flipped it down, but now I need to scooch it up 3. So move this up 3, 1, 2, 3, and then do my new points. 1, 1, 1, 1, and 2, 4, 2, 4. So let's double check that we did it correctly. Is it facing downward? Check. Did it shift up 3? Check. Double check your points. Did you do a 1, 1, 1, 1 and a 2, 4, 2, 4? I think you got them, my friends. And this takes some practice. That's why I have given you guys two activities, on Desmos.com. It's a free graphing website. You click on Graphing Calculator, and then you practice these over and over and over again, starting with the parent function of y equals x squared. If you start with y equals x squared, that's your parent function, and then you can play around and open up new windows on that same graph and see how different shifts happen, okay? I'm gonna end this video. My next video is gonna be about, well, how do we start shifting left and right, not just up and down? So come back, bye.